effective choice for all railway network located in the middle and west part of Iraq due to its low delivery cost. As an information, we have three quarry in Iraq: Sinjar quarry, Walqaim quarry, and Najaf C quarry. This research depending on only the Al-Qaim quarry ballast. Current research considers physical and mechanical properties of Al-Qaim quarry ballast material, which is one of the main depending material in the railway construction and maintenance in Iraq. Overall performance evaluation and determination, degradation of and breakage of ballast particle investigated through specially designed model test. Also, as a main aims of this research is to evaluate the Iraqi specification on railway. We have to improve railway construction and evaluation of the specification in Iraq, and this research represents when trying to shed a light on the depending requirement. As shown in this figure, the simulated model was selecting of a section of 300 millimeter and 600 millimeter with depth of 450 millimeter. The choosing of the length of simulated section is depending on the spacing of the ballast and maximum particle size of the ballast tested. This plate showing the text procedure and the model setup, which containing of a box with a dimension of simulated section, and a long layer is wood paper and 10 millimeter thick rubber sheet that replicate the typical stiffness of the subgrade layer. Ballast bed was subjected to repeated cyclic loading approximately ranging from 3 kilonewton to 10, 20, 25, 30, and 40 kilonewton. The 40 kilonewton represent axle load of a train in about 20 and 25 ton. The repeated loading were applied for 500,000 cycles at a frequency of 3 hazards per minute. The ballast damping process was simulated after approximately 100, 500, 1,000, 5,000, 10,000, and 50,000 and 100,000 cycles. Additional ballast was always added to the top of the box after each damping in order to keep the bed level underneath the sleeper as soon as possible. Material properties. As we mentioned earlier, the specification of railway issues in Iraq in 2000 containing a little test. These tests are compression tests, which required a 4 cubic sample shall not less than 60 megapascal. The tested sample exposed an average compressive strength of 65 megapascal, which comply with the requirement. Another test required by Iraqi railway requirement is a sieve analysis. Here only the maximum size of 60 millimeter and minimum size of 30 millimeter is required for the ballast. A third test was operation test. Operation test, according to the Los Angeles operation test, would not be more than 25%, while the tested material gives an operation of 6.5%. Test result representing by a settlement. After each damping and each maximum load, we make a dial gauge on the sleeper and collect the settlement occurring. As shown in this figure, all settlement will be increased in amount, and this increasing will stopping after 5 damping. Then will take a constant or allow a range of changings. Another information or representation of the deformation is a modulus of deformation of rack mass defined as a ratio of stress corresponding strain during loading load max. The model of deformation will calculated for each testing maximum load and each damping process. Here the same trend of behavior will appear, where the modulus of deformation will increase until 10,000 cyclic load, then will become to an increasing or taking a constant range. The degradation of ballast particle while taking by the dividing the box tested box in 9 sections. Each section ballast was sieved analysis and tested with maximum or the increasing in passing of number 25 millimeter sieves. This figure shows the percent of increasing for all tested material, and as we showing, all the underneath sleeper sections have a higher deformation and higher degradation. This due to the concentrating of load supplied. Degradation of ballast were under different level of load was investigated in terms of mean particle size. Mean particle size revealed an equation with R square of 0.963, while Marcel techniques revealed a breakage index in an equation with R square of 0.921. The third technique is a hardening technique, which revealed a breakage ability of ballast particle with an equation of R square of 0.958. All equations are a linear relationship with the applied load for all tested material and cycle. The main conclusion taken from this research is depending on the two aims of the research. When dealing with Iraqi railway specification, and second with the material. The Iraqi specification basically depend on grain size distribution, so more interested should be take place to extend the Iraqi railway requirement to cover other important parameters deeply. As compared with international specification, there is a lot of testing. These tests is not took place in Iraqi railway requirement. Settlement reached a maximum value in first 10,000 cycle load or after the fifth damping process. The same effect appear in the modulus of deformation but in reverse trend. It's recommended to add a degradation of the ballast particle in the specification as an additional requirement for the stability of ballast in rail track construction, especially in Iraq. Last notes, I will say it. The tested material from Al-Qa'im quarry gives a little and high deformation comparing with Najaf C quarry ballast and Sinjar quarry ballast. Thank you for your interest.
Thank you for the presentation. It was very interesting. My question is, you are focusing only on the mechanical behavior of this ballast, but there is another aspect about the durability to use such rocks as a ballast. For example, what about the chemical effect and impact? Train, there will be oils, there is another chemicals.
This side of defect we don't take in this research, but in the whole study we make some relations about the techniques of mechanical and chemical and other bio effects. Maybe ballast will subject to it. What
the settlement is it because of the compaction, or is it because of the crushing of the particles to smaller sizes?
The compaction will be as specified to maximum density. But the settlement due to the cyclic loading after many degradation of material and causing a reduction in element.
So is it important the hardness of the rock you use for this purpose?
Yes, quarry of Najaf C gives another reduction, and settlement is more or less than. But we don't have another quarries in Iraq, only 3. Sinjars and Al-Qa'im and Najaf C. We take the 3 types to comparison between them. Al-Qa'im quarry gives the weakness particle and high deformation.
Christina Georgia Chopolo.
Well, that was great.
I practiced.
Hi, good afternoon by my side as well. I would like to speak to you about the computational fluid dynamic techniques that we can apply for pipe flows that we have a lot here in Bahrain. I'm trying not to tire you, in fact, with the mathematical model, but just explaining you how we can create an original model that we can use, and small companies, even larger companies, they can use it for different applications. We have different problems at the industries here, as oil and gas, aluminium, water distribution. So we have a lot of flow inside pipes. What are the problems that we face? Leakage detection, pressure problems, energy consumption, friction losses. So definitely it's very useful for the engineers that we have here and in other countries as well to control such issues. So we need a flexible, simple model that it can be easily adaptable, and in fact we haven't produced the desired accuracy. At the following model, very quickly, that I will try to present you, we will see some steps, which are the definition and the creation of the grids that we can do for the pipes, the boundary conditions that we can apply to our numerical model, the numerical equation solutions, and finally, what is the type of results that we can extract by this methodology. Whoops. Sorry. If you are familiar with the numerical techniques that we can use in order to solve a mathematical problem, in fact, we have in the beginning to degritize the field. So in order to do that, we use the grids. So we do the grid generation, and there are different types. At the specific way that I will present you, because we prefer something simple, something easy adaptable, not so complicated, let's say even for the field engineers, we use the Cartesian grids. And you will see the application a little bit later. So how can we model, in fact, the geometry and produce it through the computer? We have to create the Cartesian approximate geometry. After that, we create a uniform, in fact, Cartesian grid. And because, as you will see, there are a lot of cells that are presented inside the field, we have to apply a refinement technique, which again is based in Cartesian methodology. Initially, in order to model our geometry, we project, in fact, the original contour to a Cartesian grid, to Cartesian coordinates. And by this way, we can pick up the different points. In case of pipes, the situation is easy, because most of the pipes, they are straight, and the only problem that you have to face in curves are some bends or maybe some thin junctions that there are with smooth angles. So in fact, in this case, the Cartesian grid generation technique is definitely the most appropriate one. That was the original, let's say, projection of the geometry. Now we have to project the geometry to our grid nodes. It is very convenient for the equation solution if you have the points on the nodes. This can be done very simple, just using, let's say, the method of the minimum distance. As you can see, probably, sorry, it will be this one, yeah. As you can see here, this point, in fact, we calculate this distance and this distance. Because this distance is smaller, in fact, we will choose the B node of the Cartesian grid. You can see, of course, very coarse Cartesian grid here, but in fact, this is initially, if you want to create the approximate bound of your geometry. So in the pipes that most probably we will face such of geometries, we will have our approximated points, which now we have to connect. There are two ways, if we want to connect them, with the sawtooth method and the diagonal method. Sawtooth method is like a scale. So you create, in fact, your geometry like a scale. Diagonal method, in fact, you use the diagonal line of the cells that you have. Here in this method, we have used, let's go back. We have used the sawtooth method, as you can see. Why? Because produce better accuracy, It is easier to apply the boundary conditions, and in fact, the mass is concerned, which is something important for us in numerical analysis. However, if you have a long, let's say, length of a pipe, the cells that are created are huge. The number of cells that you have to solve the equations are too many. Definitely, you need a refinement technique. Again, in order to simplify the technique, we use a block nested technique as the one that you can see here. We refine at the points of interest using rectangular, in fact, grids. So you will see more examples, but you can see a straight pipe that finally it will be created like that. So if we have these two areas of interest, we are able to refine, while we can create only a coarse grid in order to solve our equations at the rest of the length, which is not so important. Easily, this can be created, the refinement grid, using hierarchy, let's say, in our grids. There are, of course, some conditions. All of them, the subgrids have to be rectangular, and definitely we have to choose a refinement factor, which in our case, as you will see here, it is equal to 2. So, in fact, you divide and you divide dx and dy up to the time that you want it, up to the accuracy that you want to receive. Finally, you have created some subgrids, as we say. For example, in this tenos pipe, as you can see, we have one grid here, second, third, and fourth. The numerical simulation and estimation will take place in these separate, let's say, squares, and the solution will be transferred to each other. This is the way, in fact, that we transfer the solution and we set the boundary conditions. It's simple for the velocity. As you can see, we just use linear interpolation. But concerning the pressure, we cannot transfer it. We have to solve. So in fact, in every subgrid, we estimate again the vertical derivative for the pressure. Also, the solution can be transferred either from a coarse to a fine grid, either by opposite direction. Don't want to tire you more. If you have been, let's say, involved in fluids, most of you know that we have to solve the Navier-Stokes equations. It's nothing more than the momentum equations. We are able, in fact, to face all the types of fluids. In this paper, I will present you for laminar flows, viscous flows, some examples, but definitely we can solve turbulent flows as well with very high accuracy, with KE model as we have done. The specific numerical technique uses, in fact, the artificial compressibility term, as you can see, in order to manage to face the absence of the pressure term that we have at the equations. Here is a very simple pipe that you can see some results. In fact, the inlet area is the AB. We have an expansion ratio 1/2. Hydraulic diameter is equal to h, while the length, of course, it can be, now here in this case, it is 30 dimensional units, but of course it can be more. In this table, you can see the boundary conditions that we have used. We have given, in fact, the velocity inlet, because normally at the industry we have the flow rate which is given, and we calculate the field to the next steps. These are the different grids that we use in order to solve it. As you can see, here we have used subgrids, and we produce better accuracy with less, let's say, simulation time. The accuracy is very good at the recirculation point, as you can see, comparing with other results, while the computational time has been reduced, although the computational cells are more. But because of the flexibility of the algorithm, in fact, we earn to time. Different, you could probably see, velocity profiles. We have good accuracy in all of these. So it seems that the validation of the algorithm is good. At the pressure results exactly the same. And the most important part for the industrial engineers, the specification of the recirculation zones. The most important part is that this methodology is simple enough, produce accurate results, and can be adaptable in different industrial projects. And we hope that we will be able very soon to present a pressure leakage, let's say, detection model based on this method. Thank you so much.
Thank you.
I hope that I wasn't. This technique can be applied in any flow. For example, can it be applied around an airplane or around a car for a flow? But there, the curves that we have to approximate are more. So we have to be very careful about the approximated technique and the projection on the Cartesian grid. We have to be sure that the accuracy which is produced by the approximated geometry is quite accurate for us. In pipes, in fact, we don't have this problem because most of the parts
How do you ensure accuracy?
are just validated. So if you need, let's say, an i5 and i7 computer, and by this way you will be able to run a uniform grid. Let's say, and this one, the uniform grid solution, you will use it as a prototype, and you will validate your results.
Thank you.
Thank you very much. Thank you.
Professor Tahir is currently the Dean of Engineering Faculty at Cyprus International University in the north of northern Cyprus. His research interests include construction materials, life cycle costing, estimating construction projects, construction planning techniques, and construction methods. And Professor Tahir will be talking to us about the potential use of the sewage sludge in the production of lightweight aggregates. Thanks, Professor.
Thank you, Mr. Chairman, dear colleagues. Today I will talk about not very nice material, but sludge, water treatment sludge. Actually many years ago, I went to some university and conducted a master thesis on using sludge as lightweight aggregate. Since then, I was remembering the subject, and I'm very much interested to the investigation in Cyprus as well. What happened in Cyprus, Nicosia is the capital city of both the capital of Cyprus, which is the Greek part of Cyprus, and Turkish northern Cyprus, Turkish part of Cyprus, a common city around 250,000 people, something like this. And only one treatment plant was constructed there by the support of EU. Cyprus altogether is in the EU, Turkish part. The community is not valid, but as land, as soil, it is part of EU. So EU supported this project. And in Turkish part, we have a sewage water treatment plant. And suddenly, we noticed that huge amount of sludge is coming out. So what are we going to do this sludge? And this is why this subject was encouraged us to do investigation on it. And I have a PhD student, is Osama Alaish from Libya. He's doing a PhD on this subject. He couldn't come, so I'm going to present the subject so far we have done. Actually, the subject is quite interesting to me. The aim is not to produce lightweight aggregate, but how we are going to use it, this lightweight aggregate. In Cyprus, as a hot country, I don't know if it was here, but we use foam concrete. So first of all, by using a liquid, we produce a chemical liquid, produce a foam, mix it with mortar, and use it in concrete for heat insulation or sound insulation purposes, quite wide, especially for buildings. And our purpose is to use actually this lightweight aggregate after the dust in foam concrete. Because in foam we have problem. We studied about foam before. The foam itself has about 40-50 kilograms per cubic meter, but aggregate or the cement using is a lot heavier than this. So there is segregation, separation, there is weakness. How can we improve using foam concrete? That was actually the main target of the research. Here, what I'm going to talk today is just elementary part. Okay, sludge is used in many countries to produce lightweight aggregate, but the sludge changes from country to country, from place to place. Are you going to treat some industrial waste as well or not? Depending on this, characteristics of sludge is changing. So what type of sludge we have in Cyprus? How can we proceed? This is like this. And first, how, by which method we can produce lightweight aggregate? I will just talk about this and the first results we obtain on the left. I will explain it today. Okay, you can see this sludge. According to EU directive, this sludge is actually producing an environmental problem because disposing sludge is a problem. Whatever you do it, you can leave it in air, you can throw it into the ocean, or whatever you do it. In some countries, they use it as fertilizer. In Cyprus, it is not preferred. We don't use it. I know in some Scandinavian countries, if a food is produced by using materials which use sludge as fertilizer, they don't sell it even in the market. So there's a problem here. Okay, so as I mentioned simply here, these are the problems. So what we are going to do here, we use this sludge. We produce a sludge ash first, and we use clay also as a material, and in different proportions by insulating it at different levels of temperature for different durations, we try to produce the best alternative as lightweight aggregate. That later on we can ground and use it as ingredients for foam concrete production. As I said here, only 30,000 cubic meter of water is treated per day, and the outcome is around 1,600 tons per month, but this actually becoming a huge fire plant. So how we can use the sludge from literature, lightweight concrete production, lightweight aggregate, ceramic, road construction, brick manufacturing. And I know in, for example, Izmir, they do this to produce as a replacement for cement as well, or in production of cement, they are also using it. Okay, in literature, you can find many researches about this. As I said, these are for the sludges of those specific sludges. What is about sludge? What are the problems of water sludge? We need to investigate and find out. But you can see some research is done, and the specific gravity, as you see, is changing in this range, or in this range, or in this range. So it is really, you can produce a lightweight material. This is the target. Different alternative. Clay here is an interesting material. In San Diego also we used to use clay because after burning, clay expands and its specific gravity reduces. And burning clay is a kind of pozzolanic material, as we know. What is pozzolanic material? You can use it as a replacement of cement as well, because once cement reacts with water, some calcium hydroxides come out as a byproduct, and these calcium hydroxides are unwanted material in the cement production, because they can react with any external sulfate or carbonate or other materials, and they can create some cracks and some problems in the concrete. So we can get rid of these calcium hydroxides, reduce the amount of them half. If you can use pozzolans, that is silica in it, they can react, and some cementing property material is produced, more calcium silicates, less calcium hydroxide. So using pozzolan or pozzolanic materials, reactive pozzolanic materials in cement production, in producing cement base is very useful. That was the target actually, what we are trying to do. So here we used clay. We use Sorry. Here we use clay, sludge, sewage sludge itself, and we produce sludge ash, and then we use sludge ash as a separate material at different proportions. We talked about this. These are the dried sludge. What is the clay, or after producing an ash from sludge. And we used here 3 combinations or mixing of these materials. In first combination, I'm sorry about this. We use clay and sewage sludge. In second combination, clay, sewage sludge, ash. And the third combination, sewage sludge, ash, and sewage sludge itself. For those 3 combinations, we have different mixtures here. By changing the amount, the proportion of these materials, we produce aggregates. As you see, we mixed any 2 of those 3 materials for a specific mixture.
One minute. 1 minute.
Okay. So we insulated them 20 and 30 minutes, and I want to come here. The result we obtained that for different mixes, these are the specific gravities we produced for first combination. In second combination, these are the results we obtained. This orange color, as you see, is 20 minutes, and this is 20 minutes. 30 minutes, 20 minutes of holding time at this temperature. And in third case, this is the situation. So here, 101 is the lowest specific gravity we obtain from those mixtures. And here are my conclusions. We can produce lightweight aggregate from sludge, it's okay. Duration is an important factor, depending on the mixing proportions of them. The lowest one was 101, with a holding time of 20 minutes, and it's a mixture of 100% sewage sludge, no other material in it. And for economical point of view, generally, the easiest and cheapest combination is combination 1, because there is no ash production and this kind of thing in it. And of course, less holding time at the temperature, 20 minutes, even less is better.
So thank you very much. She's a chartered architect by profession, associate professor. She is the associate professor. Sorry, Yamuna Kanrachi is the postgraduate research and ethics director of the Built Environment and Architecture School at London Southbank University. Her research interests are sustainable built environments, innovation in construction and procurement, climate change, resilience of infrastructure, cities and communities, and stakeholder engagement and sustainability. Dr. Yamuna is going to speak to us about improving the resilience of infrastructure to create sustainable futures. Thank you very much.
Thank you very much. Good afternoon, everybody, and thank you very much for giving me the opportunity to present here in this international conference. So I'm going to talk about resilience, infrastructure, and climate change, which 3 topics which are very much in the media, in the current debate, current research agenda. So very quickly, because I've got very limited time, climate change. There's a significant impact on the built environment. It's very well established. And also, what are these extreme weather events we are talking about? It's not weather, it's not climate. But we are talking about extreme temperature highs, storms, windstorms, hurricanes, high levels of precipitation, which is associated with flooding, and also lack of precipitation, which is associated with drought. And what are we talking about when we are telling that it's got a significant impact on the infrastructure? Major disruptions to essential services, including transportation, communication networks, energy, water supplies, and also about people's health, well-being, social and economic activity, and also employment. As you know, transport disruptions can have a big impact on people's commuting and employment, etc., which has a knock-on effect on society and economic prosperity. So very quickly to go through some of the major extreme weather events, flooding is the most significant climate change risk to UK infrastructure, and the number of assets exposed is supposed to double in about 2080. I mean, these are all forecasts, these are all results after research. And when we talk about flooding, we talk about river flooding, as well as coastal flooding, surface water and groundwater flooding. So it's a whole spectrum of flooding. Storm surges and also rising sea levels, which would have a marked impact on the coastal infrastructure. Rain runoffs, again, has got an impact on the roads, dams, railroads, bridges, etc. We had an incident last year where a major connecting bridge was destroyed and the whole of England was starved of biscuits, digestive biscuits and ginger nuts. So everybody knew that, you know, because the lorries couldn't pass through that bridge. So it's felt all over the country. Right, about the transport system, just a few facts to establish. UK transport network is the most intensively used as well in Europe. Heathrow, most intensively used two-runway airport in the world. There are other busy airports, but they've got more runways, more capacity. Gatwick is the most intensively used single runway airport. So just some facts to put us in context. Strategic road network is intensively used. Operating near capacity, if somebody's been on the M25 at peak times, you know what I'm talking about. And also, this traffic volume is forecasted to be increased 45% by 2040. So in about 20 years, it's going to increase quite a lot. Major and prolonged disruptions because of extreme weather, and also direct impacts to physical assets as well as indirect impacts in commuter disruptions, then again business and societal influences, etc. And also increased emissions, because if there's a lot of vehicles stuck in traffic, there's an increase in CO2 emissions. Detrimental to the society and economy, and it's estimated 100,000 per hour for each main road affected. So we are talking about a lot of money as well. Roads are among the first cause of deaths in cities during flooding due to vehicles being driven through flooded roadways. And last year we had a basement being flooded in Gatwick, which had major disruptions for communication and IT, and it took actually months to clear the backlog. So we are looking at very severe disruptions to the infrastructure because of extreme weather. Looking at roads and concentrating on roads, as we know, roads are a key enabler of the UK economy, and maybe in any country, roads are extremely important. And it's actually UK's most expensive asset. Infrastructure is expensive. Running near capacity at the moment, it's actually causing frequent major disruptions. Flash floods are supposed to be the main cause of weather related to disruptions, and also there's a lot of heavy rain related disruptions, melting snow, etc. If you look at rail infrastructure, the most harmful weather conditions are known to be snow, low temperature, flooding, wind, and combination of these. And the main hazard that they can experience is electricity and signaling failures. Moving on. So the government recognized the need to react to this kind of infrastructure disruptions, and the Act, UK Climate Change Risk Assessment, was brought in 2011, and actually it requires the government to assess the risks and review these opportunities every 5 years, and it was updated in 2015, then again in 2017. And as a result, 5 priority areas and research areas were identified: residual risks, urban water management, and the importance of improving people and community resilience, and of course, infrastructure, and then agricultural production. So what are the challenges now and for the future? Lengthy and expensive repairs, averaging estimated 1 billion per year in the UK. So we are talking about a lot of money again. A large number of assets, 70% of railway tracks, 16% of railway stations, 9% of A roads and motorways are in locations where there is big risk. And this risk will increase. We also had very major coastal flooding near Cornwall, which washed away some rail tracks, and a lot of the local economy was affected with tourism and also transportation of goods, etc. And again, if we are talking about climate change, future climate change predictions involving 4 degrees centigrade global warming by 2080, we are talking about a lot of increased flood damage. And I put some statistics there to show 2,400 kilometers of the UK rail network vulnerable to flooding, rising 120%. So there's a lot of work to do. Rising sea levels by the end of the century will again increase the proportion of assets vulnerable to coastal flooding. There's a lot of research done, there's a lot of reviews done, and Network Rail has carried on looking in detail about the little failures, which are the components that are failing, etc. And the Transport for London has looked at case studies and what are the actions and the lessons learned. So what are the findings? Outdated design codes and standards, these need to be reviewed and changed because the climate has changed, the context has changed. Frequent testing, monitoring, reviewing, and updating. And of course, you need a lot of financial resources, not as a one-off solution, but as a long-term continuous development. And also, infrastructure systems are interrelated. If there's a problem with the rail, the roads are affected because all the commuters will have a backup option on rail. So you have to look at in conjunction. Barriers, what are the barriers in this scenario? Funding, balancing short-term delivery, and not thinking about long-term resilience. Uncertainties of long-term climate change impacts. I mean, we have forecasts, we have simulations, but some people are not so convinced to spend the money. Limited redundancies in the system, competing priorities sometimes would take the precedent. Short-term relative nature of media to individual extreme events. When something happens, we have British media is quite vocal and they get involved. And there's a lot of hullabaloo as soon as something happens, and then people move on. Regulations and legislation can also be a main barrier. And also lack of information on some impacts, such as rates of change and extreme events. Some networks have recognized this and have asked for more money, more funding, and they are putting in some resilient impacts into place. So how can we embed this? How can we embed infrastructure in sustainable development? Frequent testing, monitoring, reviewing, and updating, of course, is essential. Collaborative thinking and working is essential because it's not only one stakeholder which is involved. Frequent and routine maintenance, and new and innovative asset management techniques that identify potential failures well in advance so you can actually mitigate and adapt. Improved asset data shared by different infrastructure providers. Advanced methods and tools are needed to capture, maintain, and access high-quality asset data. Of course, Internet of Things, big data can help in this kind of procedure. And also collaborative environments and share decision support tools, because this is not only one service provider problem. The need for green infrastructure and sustainable drainage system at individual level, local, national level. And actually, Transport for London has started doing this kind of incorporating this kind of methods with green walls and vegetated track sides, etc. Need for more research, etc. And all embed resilience measures in the organizational policies to mainstream that, not as a knee-jerk reaction. Improve relationship and sharing of activities. I've mentioned some agencies which need to work together. So what are the conclusions? Improving protection for some communities will be possible, while others will face significantly increased risks. We have to acknowledge that. This will affect property values, risks and insurance, business revenues, and in extreme cases, the viability of communities. There are some areas where it's very difficult to get insurance now for even properties in England. Joint up thinking, policies, strategies, pooling of resources, investing in stable and robust infrastructure, and we need new design standards and codes which are not 50 years old. Gaps in research in areas such as economics of climate change adaptations, metrics, system modeling and simulation, and also we need spatial decision tools. So there's a lot of work to be done in that area. The major challenge is maintaining a whole system approach which balances the need of the transport as well as the other joined up actions which can work together. And again, a widely used resilience rating system which can be applied across the board, locally, nationally, and also universally. So a lot of research to be done. Thank you very much.
Well, I guess my topic is out of the civil engineering thing, but still surveying and geodesy is main part of civil engineering. My topic is how to use GPS and monitoring constructions and structures. First of all, I'm going to do a short introduction about GPS, and then I'm going to speak about structural settlement and our experiment and tests. And at the end, I'm going to go through the results and the conclusion. Well, it's just a simple introduction for GPS. I thought there can be a lot of students who was not experienced in GPS, so I prepared this for just like a basic. I'm sure everybody of you aware about this. Well, GPS, as you know, is a satellite-based navigation system where you have 24 satellites minimum orbiting the Earth at altitude of 20,000 kilometers. The very good thing, the great thing about GPS is that the measurement and observation can be taken all the time over day and night and the whole weather condition. But of course, you should have clear sky to see the satellite without any application which just prevent you from cutting any signals from the GPS. For monitoring things, for monitoring structure and deformation, GPS provide position over the time, over every second, every epoch, every minute, whatever you want to call it, time. So this provides you with a model over time, and this gives you a continuous check for the situation of the building, the stability of the building. Again, I know everybody's aware about this, about the GPS component. GPS consists of three main components. The first one is a space segment, which is the satellites over there in orbit. As it says, 24 satellites minimum. They have 6 orbits, and now there are 33 satellites. This is operated by the American Army. These satellites, they're being controlled by control segment. There's 5 stations over the world. The duty and the work of this segment is just to check the performance of the satellites and check if there's any errors in the orbit. And then they produce a message, error message, to be included in the signals. So the user, which is the third one here, the user will receive the satellite signals and the correction of the signals. The user will process the data to get its location over there. The basic theory behind the GPS was taken from surveying. We will call it in surveying resection, where you can define your location by knowing your distance to known points. So in this case here, if you see, if I know my distance from to this point, this is a known point. If I know my distance, so I'm sure that I am a perimeter of a circle, center to that point, and with a radius of the distance. We have it for another point, so we have 2 circles here, with which intersect in 2 points, and then we got a third one to define this or this. So just resection is a normal surveying thing. Now in GPS, the satellite transmit coded signals. These coded signals allow you to calculate the range between the satellites and your receiver. Now you got the range, and the satellites are, the coordinate of the satellite or the position of satellites is known over the time. So we're back to this point here. We have a known location and a distance, known distance. 3 will give me my location. It's just a matter of mathematics, solution, least squares, anything. In GPS, there's extra unknown thing, which we call it the clock for the receiver. So normally 3 satellites is not enough in GPS. We have to have at least 4 satellites to achieve the minimum accuracy required. Now, the signals coming through the GPS, there's too many errors affecting the signals. We start with the hardware of the satellite and its movement over the orbit, and then the signals transferring through different layers like ionosphere, troposphere. The third one is just the site here. You see some reflection from any flows around the receiver and the receiver clock. The receiver clock is the main issue because it is not as accurate as the satellite one. My research, when I was doing this research, was just to mitigate the ionosphere effect on the signals. Then we apply it for check the settlement of a building. Now, for my research, I use a software was introduced by Newcastle University. It's a single epoch GPS software. Just to point out what the meaning of epoch here. I said satellites provide data over the time. Any second, any minute, there's data coming from the satellite, GPS satellite. But the receiver on the ground being set to collect the data in seconds or minutes or 30 seconds, there is a setting for the receiver. They can't receive it continuously. We call it epoch. It's just one package of data coming from the GPS satellite. So each package, we call it epoch. Now in this software, the GASP, we treat each epoch separately from the previous and separately from the afterward. This is a great thing because in this case, any errors happen in previous processing or previous epochs, it won't affect my current processing. But the big issue here, GPS have only few observations. Few observations mean few number of equations, and the number of the unknowns is too much. So this will force us to apply another model to correct it, like tropospheric model, ionospheric model, and Earth rotation, too many things. So it has a positive thing that the processing won't be affected by previous errors or mistakes, but the negative thing that the number of the equation is very, very few. For our test, we choose a network in California in USA. We choose this one because the 10th of them, we couldn't find a very close station apart from the America over there. We use 10 stations over there, if you see it here, and they form a network with a baseline started from 7 to 54 kilometers. Now baseline, just about this point. In GPS world, we always use 2 stations. We put one in a known point and one in a unknown point. The one in the known point, we call it the base, and the other one, we call it rover. The line between 2 points, 2 receivers, we call it baseline. And the distance between them is obviously baseline length. For our experiment here, the baseline length was from 7 to 54. 21 minutes, okay. We processed over 21 hours. And this is the table from that network where we have the base and the rover and the distance between them. Now, we applied settlement on the rover station, 20 centimeters every 2 hours. And then we run this data using GASP software. We did a comparison between the settlement, applied settlement, and our results. And here you see, this is the result for 7 kilometers, and this is the result for 54 kilometers. Obviously, the 7 kilometers are more accurate and more precise. Well, as I say, the GPS accuracy is basement length dependent. Now, the conclusion is that GPS is very reliable equipment and tool to monitor building and constructions. The accuracy is baseline length dependent. And if you see here, we had some issue in this area here. We did further investigation, and we found out that because of the geometry of the satellites, when you have a poor geometry of the satellite, you get poor results. GPS provide real-time and near real-time monitoring system. It's very important in hazard. Say if there's anything happening to the building, if there's a sensor, it will inform everybody to leave the building or construction things because it's real-time or near real-time monitoring system. To reduce the manpower required for civic surveying, and GPS, as you know, it's used in many applications, cars, environment, farming. Thank you.
Yeah, thank you, Mr. Chairman, for the introduction, and welcome everybody. Thank you for your attendance. I'm speaking about a topic very related to sustainability, which is not energy, but it is waste production of the society. How to have an alternative to use this waste. LDPE stands for low density polyethylene. That means our bags, plastic bags, you will see some picture about it. The reasons motivate for this work are, it is as a contribution to solve Bahrain's shortage of aggregates. In Bahrain, we have a problem with aggregates. Also, as a response to challenge of safe solid waste management in Bahrain, because the plastic and the slab, steel slab, are waste. 3, to improve the hot mixes of asphalt concrete used in Bahrain, and you know that in our region is arid and hot regions, and bitumen are viscous materials. They are very sensible to changing temperatures and also for aging. It is about a background about usage of bitumen in Bahrain. In the world, we have much more, but as a small country, you see the time, it is between 1990 till 2015, the increasing of the amount of use of bitumen for roads. LDP, we found it everywhere now, not only in the shopping malls, but also in the sea and everywhere. And it is a problem, real problem. Slag. Slag is also a byproduct from the steel production or manufacturing. And we have in Bahrain 2 such factories. That is slag waste, and it should be dumped. Recycling, yes, but please, we can do it better. Here, aggregate from waste slag is not a new idea. It was used, but the combination to use it with LDPE and bitumen, that is what is new in this research. As said, we have also here a company, NAS company, contracting company, they have a crusher for slag. They are producing the slag as aggregate. What is hot mix asphalt? It is a composite material which compound, as you know, from aggregate, air voids, bitumen, and then the result is asphalt. For those who speak American English, please, we are using bitumen in European English because for them, asphalt is bitumen. The distresses in roads, as we know, we have rutting caused by bad hot mixing or fatigue cracks. We have bleeding if there is excess of binding material, and we have raveling that if we have less binding material, then may erode the surface of the road, which lead for roughness and mere noise production and maybe skidding problems. Okay, in this study we focus on utilizing of waste LDP to modify bitumen on the road pavements and also investigation of asphalt mixes with modified bitumen as a binder and steel slag as aggregate. The test was done to investigate the suitability of slag as aggregate for road pavements in Bahrain especially. If we have an opportunity, we'll expand it for the region. If the mixes meet the international standards and those of the Ministry of Works in Bahrain, if the improvement of the development by modified asphalt bitumen by adding different percentage of waste LDP will lead to improvement. That is was the LDP used was waste plastic bags or low-density polyethylene bags, and it was mixed with bitumen in certain percentage, and that's what we call it modified bitumen. We focused on this binder to test the elastic recovery. You know, bitumen, if it is more tough and more brittle, it cannot be used. That's why it should has certain elasticity. And also the softening point, which is related to the viscosity of the bitumen type, because we have different bitumen types and grades.